Hi everyone, I am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Today we are going to see the subject Control Systems, subject code EC3351. Unit 3 is Frequency Response and System Analysis. Here we are going to see the topic Frequency Response. The response of the system can be partitioned into both the transient response and the steady state response. We can find the transient response by using the Fourier integrals. The steady state response of the system for an input sinusoidal signal is known as frequency response. If a sinusoidal signal is applied as an input to the linear time invariant system, then it produces the steady state output, which is also a sinusoidal signal. The input and output sinusoidal signal have the same frequency but different amplitude and the phase angles. The sinusoidal transfer function is the frequency domain representation of the system. It is called frequency domain transfer function. Let us consider the input signal R of t is equal to A into sine omega naught of t. Here A is the magnitude and omega naught is the frequency. The open loop transfer function will be G of s equal to G of j omega. We can represent G of j omega in terms of magnitude and phase. So this is the representation of magnitude and phase of the G of j omega. The modulus of j omega is the magnitude and angle of j omega is the phase. The frequency domain specifications are resonant frequency, that is represented as MR. The maximum value of magnitude of closed loop transfer function is called the resonant peak. Next one is resonant frequency omega R. It is the frequency at which the magnitude of the frequency response has peak value for the first time. It is denoted by omega R. Third one is bandwidth, omega B. It is the range of frequency for which normalized gain of the system is more than 3 dB. Next, let us see the cutoff rate. The slope of the log magnitude curve near the cutoff frequency is called cutoff rate. Next one is the gain margin. Gain margin is defined as the value of gain to be added to system in order to bring the system to the verge of instability. The gain margin is represented by Kg. So Kg equal to 1 by modulus of G of j omega Pc. J omega Pc is the phase crossover frequency. So modulus of G of j omega Pc is the magnitude of j omega G of j omega. Here omega equal to omega Pc. Next one is phase margin. Phase margin is obtained by adding 10 to the phase angle pi of the open loop transfer function at the gain crossover frequency. Phase margin gamma equal to 180 degree plus pi gc. Pi gc is the gain crossover frequency. Thank you.